Hello, it's Sebastian Danisic again. Um, just to show you the book that inspired me to how to do recursive data structures properly was this one, A Little Java, A Few Patterns, by Matthias Verleisen and Daniel P. Friedman. It's a very unusual computing book. I like it very much. It's great. In today's lesson, so let's just show you. We can get it on eBay for $24. In England, I suppose that's about £20. I think it's worth the money. So what I want to show you today is how to actually display our binary trees. So we can actually see the binary trees we produce. Well, the best way to do this, well, the way I've chosen to do this anyway, is to use something called GraphViz. And so if you go to GraphViz, you see it's graph visualization software. And what in GraphViz, what you do is you provide it's almost like a program. Every graph you write a text file which draws the graph. But it's very simple. It's very simple to use. So, for example, here's let's look at a complicated one to start with. So let's look at crazy here. So there's a picture drawn by GraphViz. Where's the code that produces? I'm not sure. Let's have a look at another one. Let's look at Hello World. Blah blah blah. There's the picture. Where is the code? So the code is you just do an arrow from hello to world, etc. So what I've done is I've written a function, a method in Java, which allows us which converts any graph that we make into into a format that can be input by GraphViz. So I suggest you install GraphViz and so you can use this software. So just let me show you very briefly. If I show you the files that I've got now. I've got again binary tree, which is the same before, except I've added two new functions which are for drawing these binary trees for GraphViz. So let's look at empty tree. Empty tree.java. There we go. And again, the most complicated one is const binary tree. And as you see, we've got so here the two versions of 2.0 with an integer parameter and 2.0 without an integer parameter for the empty tree, and the complicated version is when we've got excuse me, the non-empty tree, which we can see is like that. But I won't bother to explain that, but I'll show you how to use it. If we look at our if we look at main.java now, so let's we can call the 2.0 function here, and we print that out, and it'll print out the output that has to go to the GraphViz. So I'll show you. We'll run that, and then we'll show you what happens. Let me run that. So I compile it. And I run it. And this is the code that comes out. So what we can do is we can pass that, we can make the output of that code go to GraphViz. Somewhere we'll find that. I've done it earlier. Eventually we'll find it, I hope. There. So that's the code, and so we call this this thing called dot, and now that'll produce a PNG file called 7 that will have a representation of 6 of T6. Well, let's start off with T1 because that's an easier one to look at. So let's do T1 dot. So that's 3 empty empty. So let's see what that looks like. So I have to compile that. And then I have to go to that thing again, if I can find it. There we go. Now if I display 7.png, I get that picture, which is exactly the tree with 3 on the root and empty as the left and right subtrees. So let's try the next one, which is 8 empty and empty. That's not very interesting. Now how about this 7? This T2 has got 7 at the root, T1 on the left, that's 3, and 8 on the right, which is T5. So it should be 7, 3, and 8. So let's we have to change that to T2. So now I can recompile that program, and so now let's make that go to T2.png. So now if I display 2.png, I get the binary tree for T2, which is 7, 3, 8, as we said. Now let's do T3. What's T3 going to look like? It's going to have 4 on the root and 2 copies of this on the left and right subtree, because we've got T2 and T2 again. So let's see what that looks like. So we've got to make that T. Which one was that? That was T3. So now if we change that to T3 and recompile that. Make that go to T3.png. So now if we display T3.png, we should see that. So there we go. We had the 4 on the root and 2 copies of this one on the left and the right subtree. So it's quite useful to be able to visualize these trees. So let's do T4, that's a 1 and 2 copies of T3. So if we change that to T4, we should have 2 copies of this one with 1 on the root. So how do we do that? We compile, we run it, and that's T4, so let's call that T4.png. Now if we display T4.png, we see that. Now if we look at the next one, that is T6, that's got T4 on the left, T1, which is this very small one, on the right, and 1 on as the root. So we make that T6. So now again we compile that, output the result to T6.png. Now if we display T6, we see that. Notice that this tree isn't balanced at all. It's got much more on the left as it has on the right, whereas this tree here is perfectly well balanced. This one here is perfectly balanced. We'll talk about those things later. Good, so that's the end of